Hey guys, so today we're going to do linear application in standard form. It's going to be a little bit different from some other things that we've done before. We're so used to there being a slope, a starting point like a y-intercept. We are so used to having y depend on x, and none of those things are going to matter in this application. So we might have it might look like there's two slopes because you might have something in front of the x and something in front of the y, and they get left there. It's going to be weird when you say the one doesn't depend on the other. We can create this standard form when we're given a total. And then once we have a total, then there's things that we can do with the information we have to learn other things. So without further ado, let's just go ahead and plow through this. Again, I want to emphasize that neither variable is dependent on the other, which is kind of new because that's all we've been talking about is y dependent on x. So here's an example. We have a 100-point test, has x questions worth 2 points apiece and y questions worth 4 points apiece. So again, we're going to go ahead, we're going to assign one of those to x and one of those to y. It doesn't matter which one we do. So I'm just going to go, well, it does the actual problem assign x to the 2 points, but if this was you're creating it yourself, it wouldn't matter. So we're going to say that this is the 2-point questions, and the x is the 4-point questions. I'm sorry, the y is the 4-point questions. And what is the total? They gave us 100 as the total. So we're going to do 2-point questions times the x. That's going to be our coefficient for the x. And the 4-point questions will be our y. And together they will equal 100. Now again, there's nothing really that we can do with this equation until we're given more information, which we are in the second part of this problem. It says if you have 15 questions worth 4 points each. So since y are the 4-point each questions, we're going to substitute 15 for the y. That would be 2x plus 4 times 15 equals 100. Now we can solve for x. So we have 2x plus 60. We'll subtract 60 from both sides. We have, I'm going to go ahead and start it over here, 2x equals 40. Divide both sides by 2. X equals 20. So there's 22-point questions. So 22-point questions. All right, let's try another one. Luis has $36. That's our total. So I'm going to go ahead and write it in right here. In $5 bills and singles, how many of each type of bill does she have? So let's see. And we're going to go ahead on this one. They didn't assign anything. So we're going to go ahead and assign. We'll say X is, we'll say it's $5 bills. And this is going to be the $1 bills. Or the number of $5 bills, the number of $1 bills. So I'm going to write an equation. So the 5 will go with the X and the 1 will go with the Y. I don't really need to write that 1. So I'm going to rewrite it 5x plus y. Just so you can see you don't need to put the 1 in front of a variable. All right, now if Luis has two $5 bills, now so we assigned x to the $2 bills to, the $5 bills to the x. So I'm going to put that in there. So I have 5 times 2, 10 plus y equals 36. We'll subtract 10 from both sides, and we end up with y equals 26. So that's 26. How many singles? 26 $1 bills. Easy squeezy. Let's keep going. Here's another one. We have 4 sandwiches and 3 salads. They spent a total of 24. Let's just go ahead and call these sandwiches. And we will call the other one salads. They told us how many I have of each. So that's 4x plus 3y equals 24. This is probably starting to look pretty easy to you. Now it says that the sandwich is $3.75 and we assign x to sandwiches. So I'm going to go 4 times $3.75 plus 3y equals 24. And $3.75, we need to find out how many is 4 of those. 30, 12, nice number right there, 15. $15 plus 3y. We're going to subtract the 15 from both sides. And again, we have some very nice numbers here. Y equals 3. So how much does a salad cost? $3 for salad, or however you wanted to write that. Again, pretty easy. Now, next one is going to be a little bit more thinking involved. All right, so let's see what we got here. We have a baby weighs 14 pounds at 5 months and 21 pounds at 10 months. Write an equation in slope-intercept form that relates the baby's weight to y. So the weight is y. And the baby's age to x. So let's call this x1 and y1. And we're going to call this one x2 and y2. And look, we're back to slope-intercept form. So I'm going to go ahead and I'm going to do the slope formula. M, remember, is y2 minus y1, x2 minus x1. We have 21 minus 14. We have 10 minus 5. So we have 7 over 5. So we have our slope. Now, we don't have enough information here, though, to write it in slope-intercept form because we don't know what the y-intercept is. So we're going to use point slope formula to figure that out. So I'm going to say, we'll go ahead and use this information right here. I'm going to say y minus 14 equals 7 over 5, x minus 5. So we have y minus 14 equals 7 over 5x. And then those are going to cancel each other out. 7 over 5 times a negative 5. I'm going to add 14 to both sides. Y equals 7 over 5x plus 7. So how much did the baby weigh at birth? If my y-intercept is 7, that ordered pair would be 0, 7. So at 0 months, the baby weighed 7 pounds. If I want to know what the baby's gaining each month, I look back at the slope because the slope is the rate of change. Now, I probably wouldn't say, hey, my baby's gaining 7 over 5 pounds a month. I would take that information and I would turn it into a decimal. So we have 7 divided by 5. Add a decimal, bring it up. 1.4. So my baby is gaining 1.4 pounds per month. So that might have looked a little bit more challenging. It did help you along the way by saying, hey, we're going to write this in slope-intercept form. And then from there, you had to realize, okay, wait a minute, I'm going to need to figure out, I'm going to need to use point slope formula to find the y-intercept. Good luck on the assignment. Ask questions if you need any help. You can do this. See you later.